755. This is option D is going to be my answer. Okay. Okay, let's solve this interesting sum, the third one. Okay. A truss consists of a horizontal member AC, CD, DB, EF. EF is actually loaded with the uniformly distributed load, and the load is P. Okay, which is given in the question. Okay, that is P per unit length. Okay, let's see how to solve this question. First, I will consider my P here. Okay, as it already given in the question, it is P. I can replace it as P into L. That is going to be my force which is acting here. So what I can say, the distance between this to this is L plus L by 2. So it is nothing but 3L by 2. Right? So why I am doing this is, first thing we need to find in this one is the reaction forces. Whenever you have a truss like this, the first and foremost thing that we need to do is the reaction force. The reaction force here, that is RA, and there is one reaction force here, that is RB. First we are going to find this one. Okay, in order to find this one, I am going to consider whichever the force acting upward is my positive. Force acting downwards is going to be negative, right? Until I complete the problem, this is going to be my rule. Okay, RA is acting upward, right? So I am going to take RA, that is plus RA. RB is also acting upward, so RB. My P is acting in downward direction, so I will take negative, that is minus PL, and the entire truss is in the rest, right? So summation of force vertical is going to be 0, is important. So I can say this is equal to 0. As a result, I will write RA plus RB, which is equal to PL. This is my first equation. And after that, how to find RA or RB? This is very simple, like taking moment. Okay, the second step in any problem, mostly we are going to take moment about A or B. That's going to be easy for me. Okay, I am going to take moment about A. That is nothing but the force which is acting downwards, that is PL at the distance of 3L by 2. And here consider clockwise direction as positive and anti-clockwise as negative. Okay, so how I can solve this? The PL is moving downwards in this direction, right? Towards, see, my A is here and my PL is acting here, so it is trying to move in this direction. Okay, the force is moving in this direction, so it is my clockwise. So I am going to take it as positive. That is nothing but moment is nothing but distance into force. So what is the distance between this and this? The distance between RA, I mean the point A, and the force which is acting is 3L by 2. First I need to write 3L by 2. Then the force which is acting at that point is PL, and it is rotating in the clockwise direction, so I am taking as positive. Okay, now RB, which is, now this is my A and this is my RB, which is acting at the distance of 3L. Okay, the distance between RB and A is 3L. Okay, and RB is moving in this direction, so I can say it is a negative because it is anti-clockwise. What is the distance? It is 3L and the force is RB, which is equal to 0. So now my work is very simple. I am going to find my RB, which is nothing but 3 into 3L into PL by 2, which is equal to 3L into RB. So I can cancel 3L and 3L. So what is my answer? RB, which is equal to PL by 2. Right? Now I'm going to find what is RA. That is the only thing I need to find. Substituting this equation 2 in 1, what I will get? RA plus PL by 2 is going equal to PL. So RA is equal to PL minus PL by 2, which is nothing but PL by 2. So let's see what is the answer here. Okay, let's see what is the answer here. It is nothing but option A, PL by 2. Okay, let's see how to solve this question. This is also very simple sum if you know the concept. Okay, before diving into this one, I would like to tell the concept. Okay, suppose if we have a force in this direction and this is my point O, okay, and I have a force in this direction, say this is my F1 and this is my F2 and this is my F3. Okay, in case if my F1 which is equal to F2, in case if my F1 which is equal to F2, then F3 which is going to be equal to 0. It's very simple, right? I can say why I'm saying this as my rule. First thing that we need to understand here is the body is at rest. Okay, whenever it is at rest, my vertical force is going to be 0, my horizontal force is going to be 0. Now tell me, what is my vertical force? Only F3. F3 is going to be 0. What is my F1, F2? F2 is going in this direction, so I can say F1 is equal to F2. Right? This is the very simple, like this is nothing but the equilibrium of forces, right? When a body is at rest, my vertical summation of my vertical force and my summation of my horizontal force is going to be 0. Here also I can relate this concept to this question. Let's see how. The figure shown in the pin joint plane truss loaded at the point M, okay, loaded at the point M, hanging at a mass of 100 kg, okay, and the member Ln of the truss is subjected to a load of. I need to find what is the tension in this one. As I already said, the tension in the KL, the tension in the LM are equal, so the body is at rest. So my Ln is going to be 0. This is going to be my answer. This is very simple one.